get started, and we'll catch somebody saying something on a hot mic.
Okay, it seems to be one of the things are fun. I want to learn more about it because I mentor climate startups. I would love to send them to this because it
is my head in shot if I stand up here? Can somebody take a look at the iPad? Is my head in shot if I'm standing?
Oh, do you want me to check?
Yeah.
Yeah, it is.
Great, thanks. Everybody has a shared job. If I absentmindedly wander off the stage while giving some sort of philosophical remark, remind me that nobody's manning the video. I have to stay on the stage. So thank you all for coming this evening. It's really exciting to have everybody here. About 7, 8-ish years ago, I was winding down a well-intentioned and poorly conceived startup, and I was looking for opportunities, and an old friend of mine asked me if I wanted to work in the oil and gas services industry, and I was like, are you kidding me? But we talked about the problem of methane leakage and super emitters, and I was very interested because I realized at the time that the carbon crisis was really the most important issue of our generation, and that we didn't really have much of a chance if we continued operating in the fashion that we were operating. So, oh, and friends at the back, I want to let you know there are some extra chairs over here. There's a couple spots on the couch, so if you guys are all squished in, you're welcome to find a chair. I started working at Kairos, and I was really taken in by the amazing work that we were able to do to mitigate the carbon intensity of our atmosphere through some pretty low-hanging fruit. And I gave a talk at PyCon about the work that we were doing, and a bunch of people came up to me afterwards like, this is amazing, this is really cool, I want to work on climate, I don't want to work on ad tech anymore, what do I do? And I was like, I don't know, like call your senator probably. And in all honesty, that is actually one of like the highest value things you can do if you don't live in like the state of California, right? So, but I got to thinking about this question. There's a ton of people who are really talented and they're really energetic and they really want to make an impact, and their bosses are telling them that they're changing the world by like, you know, supplying dog food on demand or whatever. And they want to do something meaningful, something that they find meaningful. And so it occurred to me that there was a real mismatch between the talent that was needed to solve the climate crisis and the people who wanted to do that work that were doing other work. And I wanted to find a way to bridge that gap. So I convinced some people at Kairos Aerospace, hey Kevin, I convinced some people at Kairos, Kevin is also doing amazing things to take carbon out of the atmosphere. So I convinced my friends at Kairos Aerospace to give me a little bit of money to help give something of a voice in climate activism to a company that was really mostly facing the oil and gas industry. And if you sort of walk into, you know, ConocoPhillips' office in Houston and you're like, we're here to help you with your carbon footprint, they go. So, you know, that's actually not true anymore. I think at the time we were doing it, that was true. Now they actually care. But we really wanted to, I know a lot of people wanted to be involved in like a more activist focused work among my colleagues and my friends. And so we started with some online networking because it was COVID and nobody was really talking to anybody. We moved after COVID into live events, and it's been really electric. It's been really great to have so many people who are so interested in hearing about these topics show up on a Wednesday or Thursday evening to talk about them. So thank you all for being here. I also want to say, of course, thank you very much to Aaron and to Elena and to Kairos Aerospace for funding not just Kairos over the years, but this panel specifically is sponsored by Kairos. This is an area where I worked for 6 years doing GIS and just like figuring out where the methane was based on, you know, squiggly lines on a computer. And it was really exciting. So I am going to be moderating this panel because I know enough about it to moderate it. and that's fun. I want to encourage you to check out the CTAN Substack, where I provide weekly based opinions about climate things. My latest post was titled "Why I Hate Elon Musk." So that kind of opinion. We have been changing over our ticketing. So if you are here and you purchased a ticket, thank you. I really appreciate it. We are trying to cover our operating costs, and the tickets do not cover our operating costs, but they do help. And if you work for a VC or anything that has like venture or capital in the name, and you come to these events and you think to yourself, I have left better informed and better able to do my job, and this has brought value to me and my company, if you can get your money out of your bank, please consider, dark humor, please consider writing us a very, very small check relative to the size of your overall portfolio. You can contact me, info@ctan.cc or at matt@climatetechAction.network. And yes, .network is a top-level domain. So with that, I am going to introduce the panelists for today. I'm Matt Gordon. I am a physicist, software engineer, climate activist. My current day job is at Toyota Research Institute working on batteries for EVs. I will call on you last, but in order from right to left, Olya Ursak is I'm actually quite proud to say that Olya Ursak is a friend of mine and an old friend of mine, and somebody who I often go to with questions about climate stuff. Olya is the founder and CEO of Frost Methane. Previously, she was system architect at Zola Electric, enabling mini-grid in remote communities. Google X, prototyper on early-stage climate projects in geothermal HVAC and long-duration storage, and a team lead at Google Energy on smart grid technologies. Olya is the instigator of Diamond List, a compilation of early-stage climate companies, the Clean Tech Expert Network, tech due diligence for VCs, and is on the board of Terraformation. She speaks 5 languages and has a mild kite surfing addiction. Everybody, let's hear it for, no, I'm just kidding, sorry. Moving to the left is Julian Klein. Julian is Senior Director of Product Management at Picaro. Julian leads the product marketing at Picaro, focusing on the natural gas industry. He brings 20 years of experience managing technology products and leading market initiatives. Julian was born and raised in France, where he received his BS and MS in applied physics from École Polytechnique. He also holds an MS degree in electrical engineering from the University of Michigan. He has happily called Northern California home for the past 17 years. And finally, my former colleague and also friend, Aaron Weatherly, is the Director of Research and Development at Kairos Aerospace. Kairos is a holistic methane partner for energy industry customers, helping them optimize their methane programs and providing evidence-based results to prove their success. Aaron's R&D team is responsible for all things science, including sensor development, calibration, signal processing, and data analytics. Aaron earned her PhD in geography, specializing in remote sensing from the University of California at Santa Barbara, and has also worked as a consultant, GIS manager, and science radio host. So these are our very eminent panelists, and I want to say that these are probably 3 of the best educated people about methane in the Bay Area. So thank you guys for being here this evening.
Sorry, can we crack open a window in the back? It's kind of stuffy. Thank you.
Fans of the CTAN 1.5 panel, C-panel event will know that I usually like to start by talking about the problem in general, and I usually try to highlight at least one unit of measure that's relevant to the problem, because I'm a physicist and units are the bomb. So methane, CH4, is a colorless, odorless, highly flammable gas. It is the primary component of natural gas. Methane is responsible for about 30% of global warming. And if you did not know this, the smell that you smell from natural gas is not the smell of methane. It is added to that so that you will smell it if it's leaking in your house. Over the last 250 years, the concentration of methane has increased by 167%. Agriculture and energy are the two biggest sources of anthropogenic methane. I thought I had, I'll get to that. All right. Methane has 20 to 100x the global warming potential of CO2. And this is actually a really interesting and important and subtle point that we will talk about a little bit tonight, and I'm going to write about this week. But it is actually a very tricky number to pin down, because if you look at the carbon dioxide plot on the left, it shows you that if you put a pulse of carbon dioxide into the atmosphere, it stays around for a really long time. Whereas if you put a pulse of methane into the atmosphere, it breaks down very quickly. So the question of what the global warming potential, which is essentially, that's measured in units of CO2e. So it's the if you add a megaton of CO2 or a megaton of methane, methane has, say, 100 to 20x the GWP, or CO2e, so it's 100 CO2e of methane. So that's the unit we're talking about. GWP is time dependent because it's much more potent when you release it, and then it breaks down in the atmosphere over time. So I remember Elena and I were at a Climate Link event, and some woman in the audience was very passionate about people using the right number, and she thought everybody was using the wrong number. So this is a great way to start fights with. Oh, yeah, that's right, you were there. People, this is great, and like nobody knew who she was, but she was really passionate about it. So it's a great way to start fights at the methane bar. Basically the two forms of methane that are most important in California, it's actually agriculture, and a lot of that comes from enteric fermentation, which is basically cow poop, cow burps. But a lot of what we're going to be talking about tonight is natural gas in the energy industry. We pull it out of the ground, we ship it around, we burn it, and also other parts of the energy industry like coal. Over the last 250 years, the concentration of CH4 in the atmosphere has increased by 167%. And I think that's all I really wanted to tell you in terms of background about methane. So at this point, I'd like to turn it over to Aaron. And Aaron, I'm going to pull your slides up here. Go. Oh, that's terrible. Oh, there we go. Okay. Go.
Hello. Yes, thank you for that introduction. My name is Erin Weatherly. I'm very happy to be here speaking with you. I brought a couple of slides that I hope will help illustrate how we see the problem of methane and really our strategy to address it. So I do have some slides. This first slide is just, it's an area. You can see there's a town. This is something of a satellite image. Yeah, there's some open space there right next to that town, and I want you all to put on your imagination caps. Imagine that you, in fact, work for an oil and gas company. You are the person responsible to go out and visit all of those oil and gas sites and make sure that they are not emitting methane.
Whoops.
These are all of the sites that you're going to visit. It takes a while. Generally, if you're going to do a very comprehensive search of each one of these sites, you can expect to do about 8 per day. That's what we hear from our oil and gas partners. Oh, and also, you have some pipelines that connect all of these sites together, and of course, these pipelines could be the source of methane as well. As Matt just mentioned, methane is odorless, it is colorless, so you're going to go out with some technology. You might have a camera, you might have a sniffer, you might be listening, but your ability to actually know where to go first is probably going to be dictated by a maintenance schedule. Like what is the easiest, shortest path? How am I going to go do this? That seems like a big task, so let's imagine that I gave you a different map.
That's the worst.
Let's say I gave you this map. I think that we know which site we want to go to first. We probably want to go to that site that's emitting 14,000 kilograms per hour of methane. And we probably want to go to that other site, that about 170 kilograms an hour of methane. That's probably stop number 2. I think right now it's very clear where you want to go, and the fact that you're able to prioritize those quickly means that the overall methane impact is going to be much lower than if you started at some completely different site and slowly worked your way over to that location. So that is one major contributor, one major strategy that Kairos helps contribute to. We, last year, through our efforts, helped to prevent something like 43 billion cubic feet of methane from entering the atmosphere. Another way to think about that is about 71 million metric tons of CO2e, so just that's the equivalent if we were to prevent that. You can also think of that like keeping roughly 15 million gas cars off the road for 1 year. We're very proud of this impact. And we're very proud of the fact that our impact is growing every year. Last year, our impact was 1.7 times that of the year before. This year, we're on track to be much more effective than last year. So we're growing fast, and we're very proud of that. The way that we do that, or one major way that we do that, is through a technology that we have developed. It is a pod. We attach it to an airplane. We're able to fly that plane over very large areas of oil and gas production and find significant methane emissions. So that's essentially a major strategy in how we do that. And our clients, of course, are oil and gas companies who are looking to improve how they mitigate their methane and do it the most effective way possible. So I have a couple of slides that are actually going to dive into some of the data sets that we've generated over the last couple of years, just to show the scope of the problem of methane and large methane emissions from oil and gas.
I just want to point out really quickly, so speaking of what we're talking about, metric tons of CO2e mitigated, 70.8 million, based on a GWP 20 of 85. So we were talking about global warming potential. GWP 20 means in 20 years, what will the GWP of that be? And it will be 85 times that for CO2 per pound. That's correct?
Sorry, I think it's cumulative or warming.
This is the point you made over an email. I'm trying to keep it simple, but do you want to explain it in more detail? Yeah, no, go ahead.
Yeah, so you saw in Matt's original slide where there's like a pulse and it kind of goes down. So what it does is cumulative, including that half-life, it's kind of cumulative warming over 20 years of what a methane molecule released today would trap versus a molecule of CO2 released today would trap kind of over the next 20 years. Right?
So it's an integral as opposed to a point here. Yep.
Yeah.
So it would be higher if we looked at 1 year, it's lower at 20 years, and it's lower over the course of 100 years. So I'm going to show you some graphs and plots. I like graphs and plots. I hope some people here like graphs and plots too, because you're in for a treat. So this big strategy of Kairos, or a big strategy from our very beginning, is we have to go big. We have to go big to find the big emissions, because we know that big surveys are going to find those big leaks. So this is a data set. It's actually 2021. I didn't have time to put together a more recent histogram, but it's roughly the same this year as well. This shows all of the detections that we had in the Permian Basin. The Permian is a very large producing basin of oil and gas in the United States. It's a border between Texas and New Mexico. So you can see that very long tail on that graph. Those are some of the biggest emissions that we have seen. We call that the tail, or the heavy tail of the distribution. And just that one tail, where that sort of upper bracket is, that's roughly 0.1% of the sites that we surveyed, and it's roughly 40% of the field methane coming from those 0.1% of sites. So just in terms of probability, these are exceptionally rare across the landscape, but they are there. Overall, that entire histogram represents all of the detections that we have, all of our survey. Those all come from about 1% of the sites that we survey. So again, being able to go big means that we can survey large areas and find these emissions. Another benefit of big surveys means that we find emissions in places where we might not have expected in the first place. So this is something that was kind of an interesting development. Matt might even remember back in the day. When we first started flying, we were seeing emissions coming from not wells, emissions coming from the middle of fields. And we realized that in fact these were coming from pipelines. And up until then, that was almost completely lacking in the literature, the presence of large emissions coming from pipelines. It was something of a surprise. the large pie chart up there, that's from a study coming out of some JPL affiliated folks. You'll see in their data also of the Permian, they're finding about a quarter of their methane is coming from pipelines. And so the only reason we know is from these big surveys that are looking everywhere. And I threw lots of little pie charts up there that are way too small for you to see anything, but if you were able to look at them more closely, you would see that there are no pipeline emissions there. And that's not because there are no pipeline emissions, because those studies were only looking at certain well sites. They were not even thinking to look at pipelines because they didn't have the ability to survey big. So we're able to find methane wherever it is, regardless of wherever we expect. And the last piece of this that I want to talk about is, again, scale, but in terms of not just flying big, but being able to survey areas rapidly. If you think that you have a very small emission and next door you have a very large emission, and both of those emissions are going to be persisting for the same period of time, obviously the effect of the big emission is going to be larger than the small emission. So we want to be able to survey rapidly to find these big ones quickly and reduce their impact overall. So a big part of our scale is just getting bigger and better so that we can survey more quickly and go out more frequently and help our oil and gas company clients reduce their overall impact of their emissions. That's what I got.
Great. I want to point out one other really cool physicsy thing here. This is one of the things that's always fascinated me. On the left there, that distribution, if you sort of assume that the zero part isn't really there because things can't be really, there's zero things because we're not detecting them. This falls off very rapidly. It starts very high and falls off very rapidly. It's called a power law distribution. The power law distribution is one of these fascinating things that you find all over nature in like crazy places, like the distribution of the sizes of lakes by area in Minnesota. Things like that. They occur out of naturally occurring processes. I actually talked with Brian Jones about this question fairly recently, which is why do you expect to see, from a fundamental physics standpoint, power law distributions, not just in oil and gas industry, but in everything? And it's actually quite a complex question of complex systems, how you get these what are called scale invariant systems. So this is something that I'm really interested in. So next, Julian, I'm going to put your slides up. There we go.
Thank you. Thanks. Great to be here. My name is Julian Klein. Work for Picaro. We are a small company based in the South Bay. We're in Santa Clara, so actually neighbors with Kairos. We have been around for about 25 years. We're still a privately held company. So being in Silicon Valley for the past 25 years, being venture backed, I'll let you guess if we are customers of SVB. We might not be. I'll just leave it there. But we're okay. So we have this technology that we have actually developed quite a while back called CRDS, cavity ring down spectroscopy. So building simple optical cavities with mid-infrared or near-infrared lasers and circulating air samples in those cavities looking for traces amounts of various gas. So Picaro has made a business out of measuring trace amounts of hundreds of different molecules, including methane. Turns out methane is a quite simple molecule to detect with this type of technologies. So for the past 10 years, we've been pursuing applying our technology to detecting methane. And we found early success with a number of companies, especially in the distribution sector. So when I say distribution sector, think about all the maintenance services bringing natural gas to your house. So in the Bay Area, PG&E, in LA, SoCal Gas, and so on and so on. Every state, every county has a different supplier of gas. So if you look at the breakdown of emissions, fugitive emissions coming from these operators or distribution operators is actually a very small fraction of emissions in the US. Just a few percent, but it's that network, that infrastructure of distribution is highly visible, right? It's everywhere, no matter where you are, you see them. You know these companies' names. When a house blows up or there's an accident, this is highly visible. So it's a big deal for these companies to have a strong posture on emissions reduction and safety. For these companies, it's really a matter of earning the right to do business in our communities for the next generation. So even though they contribute a relatively small fraction of emissions to the problem, it's a big deal for us. And so our technology is particularly good at finding the type of leaks and fugitive emissions coming from distribution network. And you'll see a lot of parallels between my remarks and what we just heard from Keros. It's just at a different scale. So if you go to the next slide. We've been at this for the gas distribution business for about 10 years. We do business with about 40 customer partners all around the world. We have a big footprint in North America with a good fraction of the major operators, as well as multiple distribution systems in Europe, Italy, Germany, England, France. So we're on a journey ready to empower gas distribution utilities to do a better job finding their leaks, managing their networks, reducing their emissions, and be safer. The way we do it is we embed our detectors essentially in the trunk of vehicles, and we drive these vehicles on publicly accessible roads that just happen to mimic the gas distribution network. So we just leverage roads basically to cover these pipes. And the cool thing is we actually leverage wind, right? Atmospheric conditions to propagate methane plumes from those leaks, whether they're above ground or below ground, to the vehicles. So it's really a statistics of probabilistic game. We have to drive enough times in these streets so that the wind conditions will be such that we can intersect with the plumes, find the methane. If we drive enough times, we can build up statistics on this, and then over the past 10 years, we've developed very powerful ways to analyze that data and extract leak information from that data. So not only can we pinpoint, find leaks, we can also quantify the flow rate of these leaks and to about an order of magnitude, right? So we can distinguish very small leaks, medium, and large leaks. And that turns out it's a very powerful capability, just to be able to bin emissions and bins leaks in order of magnitude bins. On the next slide, you'll see why our customers care and why we're having a lot of success these days is because all our customers are on this journey to net zero, right? Many of or if not most of the top 50 or top 100 distribution systems in the world have committed to being net zero in terms of them transporting the gas from the city gate, when they take ownership of the natural gas, all the way to the meter set of their customers. So in order to do that, they have to find a way to abate emissions. And sure enough, if you look at the typical distribution of leaks in a network, it follows that same parallel that you were just describing, and with a very fat tail. So our figure of merit here is if you look at the large leaks, the top 2% of leaks, you just take that slice of 2%, that's almost 40% of the emissions coming from an entire network, thousands and thousands of miles of maintenance services. And if you take the top 5%, you're over 50%. So here you may notice that the size of the leaks is very different. We're not talking about hundreds of kilograms per hour spewing in the atmosphere. A very large emitter in a distribution network is a very small fraction of this. So to the order of 1, 10, 20, 30 cubic feet per hour. And on the right side, you'll see the different technologies that are good at capturing these events. In order to capture the full spectrum of emissions from the distribution network, you need to be able to be pretty sensitive. And so our technology is a very good match to the median or the average size of a leak in a distribution network. That's why our systems are very powerful and can be deployed at scale to drive entire networks, find those leaks, rank them, find the big ones, and go after the big ones.
One thing I want to point out before we move on is one of my favorite things about working in the methane industry. You'll see the leak size here is listed as cubic feet per hour. nobody can agree on what the units for methane leak size are, and I actually wrote an entire 2-part blog post for Kairos about this.
Which I read.
Thank you. Wow. Which explains the difference between cubic feet per hour, kilogram per hour, standard cubic feet per hour, standard cubic feet per day, ppm, ppb, and what they're all used.
Methane per year.
Exactly. Oh yeah, BTUs per year. You know, just
Liters
like
per second.
Liters per minute.
yeah, exactly.
Per hour.
It's just you know, it's like rent 525,000 liters per hour. So there's a lot of different really confusing non-conforming units. And so if you ever find yourself in a position where you really want to know about this, you can Google Matt Gordon Kairos leak units and you'll probably find it.
One of the first things we did when we started working in this is have a spreadsheet where you can type in any one of those units and it'll convert to the other ones.
Yeah, and in fact, there's now Highwood Emissions has that on their webpage, and we link to it because that's really handy.
Yeah, as we've been expanding from North America to Europe and to Latin America and Australia, we have a really hard time reformatting all our material,
Yeah,
all our
exactly.
products to go metric.
It's like the
very
dirty
painful.
secret of the industry that everybody hates. It's just like all the different units. That's why I love units. All right, sorry, moving on.
Yeah, and so finally, again, another powerful reason why our clients want to work with us and want to deploy our technology. You know, imagine PG&E, right? 50,000 miles of main pipes flowing all over Northern California. They drive every single mile, every single pipe, every year with our technology, and it's a painful process, right? They have to deploy. We have about 10 to 15 cars with our equipment that are operated by PG&E every night from sundown to sunup. They drive their entire network for the sole purpose of finding emissions, reducing emission, and improving safety. So they're really committed, and all our customers are headed this way. And so what's powerful about it is if you stop thinking about these, you know, hunting for these super emitters, these large leaks, finding them, fixing them, you can start modeling the impact of a program like this, not only over 1 year, but over multiple years as you keep raising the bar, right? I'm gonna progressively clean my network, one step after another, go after more, lower my detection threshold, and keep inspecting more and more often. And what we're telling all our customers is if they implement our technology, in less than 10 years, they can take their operations, all the people who work in this industry, they're quite conservative, they're hard to convince to change, but you can take them step by step by the hand, and in about 10 years you can convince regulators, the public opinion, stakeholders, the financial markets, that you can abate something like 75, 80, and maybe even 90% of fugitive emissions. And so that's the powerful proposition we're making to the market, and that's what we're going after. And by the way, we need a lot of help doing this. We're ramping hard, and we do need to hire more folks to help us. So
There are a lot of job seekers here, and this is one of the main reasons we exist, is to try to connect people up with jobs, because you don't want to be working on that tech anymore.
We're hiring as well.
And finally, frost method.
Hey, so these fine folks find all the leaks, and then for some sources, we go and mitigate them. Although I don't think you guys have flown over coal mines yet. Although that's something where it's less of a detection issue, and it's much more about the fundamental geology, which is well known, so you can kind of compute it out anyways. So one way or another, we identify these high impact sites. For us, often it's based on the fundamental geology of the site. So not quite yet using the sophisticated technology. And what we look for is these high flow sources of a really potent greenhouse gas that are otherwise absolutely unregulated. So nobody has any responsibility to do anything about them. Right, so we find those, we install our devices that fundamentally just burn them. Right, so 1 molecule of methane to 1 molecule of CO2, which is why I have very strong opinions about the equivalencies, because all we do is transfer one into the other. In certain cases, you can do something a little bit more useful with the heat. In some cases, you can turn it into electricity. In some cases, there might be some local usage of the heat on site, but these are somewhat uncontrolled sources, and so the kind of seasonal fluctuations that you see on top of them often means that you can only put the lowest CapEx machine on this, and for this to still make sense. After that, as these things burn, often for, in theory, we are not that old, but in theory, this should work for decades. We issue and sell carbon offsets, which is the only reason that this is possible, because otherwise there's no regulatory obligation to do anything about these specific sources. Next slide. Alright, so the sources that we look for. Unregulated high flow continuous methane sources, semi-continuous. So the first thing that we did was we actually went to probably the hardest thing possible, which is the permafrost, found a continuous methane vent there, and took, together with our partners at the University of Alaska at Fairbanks, the first measurements of that crazy source. This is the more abrupt and continuous emissions of methane. There's also in the permafrost diffuse, slightly better measured sources of methane. So the natural sources, the reason that there's the approximation in there is because nobody has any real clue, right? There's one professor in Italy, one professor in Alaska, and one professor in Russia that look at these kinds of emissions. So who knows, maybe you guys will fly over them and find some more. Active and abandoned coal mines. So coal mines don't have any responsibility for their methane except for safety, right? This is not quite as crazy as it sounds, because it really is on a case-by-case basis. Lots of coal mines don't produce any methane at all. And when they're shut down, it is impossible to seal against it, right? So it's not like oil and gas wells where you pour you make one hole in the ground, you pour some concrete and you're good. In the case of coal mines, as the mining happened, there's thousands and thousands of fractures. You cannot seal against them, right? You can maybe flood against it and the hydrostatic pressure keeps it in place, or you suck out the gas and you burn it, which is our approach. Similarly, manure ponds, right? So that's the one agricultural piece, also produce reasonably large amounts of methane. In the US, actually more than coal mines, although that's not true worldwide. And very similarly, it's producing the methane, there's no responsibility for anybody to take care of that. And so that's why all of that stuff falls under carbon offset markets, which is the kind of gap stop of when it isn't covered by regulations. Also, old landfills are in a similar category. All right, so we basically fundamentally burn it. We have a low-cost flare that is robust to different flow rates, different gas compositions, really small, really modular, really easy to literally hike in with, because we did. The Arctic has no roads. Everything's on like inflatable boats, it's kind of weird. Anyways, and then a remote monitoring system, because the carbon markets, despite what you may have heard, at least for methane, have really, really strict rules of how you measure it. The precision that you measure it, your sampling rates, you miss like a 15-minute sampling and you don't get paid for that, down to how frequently you calibrate your methane sensors, right? Because methane sensors, well, the lower cost methane sensors drift. I don't know about yours probably don't drift. But for something that you can afford on that, it absolutely does, and so you better be calibrating at a given interval. Next slide. So yeah, the carbon offset markets, just a quick plug for that. They are growing really, really rapidly, right? This is a map of both cap and trade and carbon taxes. Some of these like regulations include offsets, some of them don't. All international aviation is going to be under a cap, and anything above that cap needs to get somehow reduced or offset. So these are growing reasonably quickly. And the nice thing is that the voluntary and the airline markets allow for this to happen in other places. Because the US has a really dense pipeline, like natural gas pipelines. And so in some cases, these sources of methane that are so isolated and so small that they can't be used for anything else, in other places, there's huge sources of methane that in the US would have been put in a natural gas line by an enterprising oil and gas person, which is the right thing to do, right? If you can afford that, that's worth it. But all of the sources that we're looking at are not profitable to do that. And that's it. If you guys, if you guys want to help, then introduce us to. If you've got a cousin that has a manure pond, send them our way. And we are also.
Best pickup line ever.
And we are also hiring for a business development and partnership.
Okay, my cousin's got a manure pond. All right, so I want to.
The number of shit jokes.
Yeah, no, exactly.
We're gonna have T-shirts that say "Ignore shit." It'll be great.
Oh, that's so good. So I just want to. That's fine. We don't need it. Apologies in advance to the panelists. I did not include some of the questions that were requested because we're not going to have time to go through all of them. But let me start here. So, the U.S. emits about 660 million tons of CO2e of methane per year, or about 22 million tons of methane, and roughly, in whatever sort of proportionality you want to talk about it, the verticals that you're covering, what's the rough proportion of that contributed in, say, the U.S. or the global, markets? Are you saying, what percentage of the problem are you addressing? Like, for instance, Aaron, what percentage of the problem is probably being addressed by looking at the oil and gas industry?
I'm sure we're all up to date on the latest version of the EPA's greenhouse gas inventory. The draft was just released about a month ago.
Oh, you mean Quado AC, or whatever it is called?
Every year, or every other year, the EPA releases a big inventory of all of the greenhouse gases that come from different industries across the U.S. It's not just methane; it's carbon dioxide, it's other gases as well. I happened to take a look at it the other day. Currently, if you look at the combined contributions of natural gas, petroleum systems, abandoned oil and gas wells, the EPA pegs that at about a third of the methane total. However, I would also direct you to several depressing scientific studies that might indicate that the EPA is perhaps underestimating slightly. And when you look at some of those publications, one that I found in Science thinks it's about 2x underestimate, and you fold that into what the EPA is saying, you start approaching about 50%. So that's obviously a very large swing, but it's enough to say that oil and gas is a very significant portion overall.
At the time we were working together, we had published papers that suggested that the numbers were about 9x higher than the EPA, but I'm assuming that the EPA has caught up in terms of data and is now only slightly, a smaller number of fold below that. Is that what you're saying?
No.
Maybe I'm misunderstanding.
But I would say that since your time, we've had the opportunity to do large surveys of many basins in the United States. We're seeing some very interesting variability. We have had some disturbing surveys where we've found very high emissions and lots of opportunity to stop methane. Other basins are different, and so I think there's still a lot of really interesting questions that we're going to be able to answer as we get better data. And for right now, we're just doing our best with the models and the data that we have.
And what the work that I was talking about only covered those basins, whereas you were talking about numbers that were based on a much broader base of emissions from abandoned oil and gas wells and other parts of the energy sector, but including the municipal gas. So Julian, what do you think? You said that you think that municipal gas is a small but important part of the problem.
Yeah, absolutely. It is small in raw numbers, but I think the influence and the social impact of these gas utilities is pretty big. And another thing they can do is they can actually control where the gas flows from, right? At their city gates, there are lots of projects for these utilities to source responsible natural gas, renewable, RNG, right? There are a multitude of standards that are emerging, and these utilities have power because they can actually mandate from their upstream and midstream suppliers to only consume specific types of gas. All our customers are also piloting projects around hydrogen and trying to blend hydrogen in their networks, and they all have a lot of appetite for understanding how hydrogen behaves, leaks, what's the impact on the atmosphere, and so on.
I was actually reading about that, and one of the biggest problems with mixing hydrogen into the natural gas flow is that above about 2% hydrogen causes steel embrittlement, and the pipes start to fall apart. So there's significant fundamental physical limits on what we can do with the existing ancient, creaky infrastructure, but hopefully we can surmount those problems at some point. And oh yeah, I'm very interested to see now that you're working on enteric methane. That's great, because enteric methane here in California, well, enteric meaning all the.
Yeah, so we're just working on the manure pond. If you guys are interested in the burps, then Algae Bioscience in the back there are the ones to talk to.
I did want to get a cow burp company up here, so I'm sorry I missed you guys.
I registered late.
No, I was trying to find somebody on the panel, but for the panel, but this is a great panel. But yeah, no, that's actually these are much bigger sources for California. So what about you in terms of the overall impact?
So manure ponds are about 9% in the U.S. Like of U.S.'s methane emissions. Coal mines are about 6%, and the very, very small fraction of let's say like old landfills that would be relevant to our tech, maybe 1 or 2%. Worldwide, the numbers are pretty different. Specifically in the US, oil and gas is such a huge emitter, and that is not true worldwide, right? Worldwide, coal is methane emissions from coal are as big as from oil or from gas, but not oil and gas.
And I just want to say that one of the reasons it's such a great top project to work on is because even dealing with 3% of the problem in terms of methane is dealing with 300 times, like 100 times that.
And the natural sources, who knows?
Yeah, methane's it's very low hanging fruit in terms of like our ability to have impact on climate change. The IRA introduces new fines on U.S. energy producers for methane emissions. How will this impact your business? Probably most directly Aaron's business.
Yeah, it's a very interesting time. Our oil and gas company clients are definitely aware of this. They're anticipating the effects of this as well as other regulations that are coming down from the EPA. I think they see this as a big challenge. It sort of puts them in a position where they need to be able to prove that their efforts work, that they have data to prove that. And that's something that actually we're pretty well positioned to help them with, to both use evidence to go out after these major emissions, and then to actually have the data to show to regulators or whoever, hey, yeah, we went out and we fixed this, we're pretty clean. So it's a big change, but we're gonna make sure that the oil and gas industry, to the extent we can, is prepared.
Julian?
Yeah, distribution operators are not directly affected by that potential fine. They're excluded from that category. Actually, DSOs, the distribution operators, are regulated by DOT, Department of Transportation, not by the EPA. So they belong in a different regulatory framework. It's all very complicated and confusing. And then you add the state level in the mix, and it's an interesting landscape to navigate. But we do see trickle-down effect, right? All these utilities are paying attention to these potential fines. So putting a price on a metric ton of methane is very important, because it encourages all our customers to start thinking about ROIs and kind of monetizing the impact of their efforts, even if it's an internal exercise or something that they can report to their investors or the street. So I think it is helping, it is pushing things in the right direction.
Does anybody here besides you know who regulates the oil and gas industry in Texas? What the organization is?
The railroad.
The Texas Railroad Commission. I don't know what the history of that is, but yeah, but there's the energy industry gets sort of regulated from weird directions sometimes. But those are also like 5 of the most powerful people in terms of like the ability to actually make change.
Not relevant to us.
Not relevant at all.
Not the whole IRA.
Does the IRA have any provisions that you think are impacting your business?
It's not super clear about what the agricultural provisions are going to be at. That's like had a lot less clarity. They're going to look much more like carrots than like sticks. There's some pretty cool stuff on trying to utilize abandoned mine lands for a variety of projects, which I think is like genuinely a really good idea. So also carrot though.
So according to the IEA energy tracker, People's Republic of China is the largest producer of methane at 28 million tons per year, followed by Russia, 18 megatons or million tons per year, and then the US, 17 million tons. So the US is only responsible for about 9% of global methane emissions. what can the world do, or what can we do about really thinking about and improving the methane emissions in other countries, some who are the largest producers are hostile to the U.S.'s interests, like the PRC in Russia, from a political standpoint.
I'll at least get that one started because a lot of the China one is definitely coal mine methane. So they are part of the methane pledge. There's some really interesting tech that's coming out of them as well. That's all kind of coal mine related, a little bit on the like lower concentration levels. So I think there is, given that there's political efforts both in the methane pledge and in carbon markets, which also include that in like Chinese carbon markets, I think that they're moving in the right directions. On the Russia side, I think that's a very different story.
You don't all have the answer, but if anybody else has comments on this, I know it's sort of a complicated question.
Yeah, our ability to have an impact on China and Russia is very limited at this point. So we're not really in these markets. We are seeing a lot of traction in Central and Eastern Europe, you know, in that sphere of influence of the EU and NATO. So we are going into, you know, Poland, Czech Republic, number of countries. So, but yeah, Russia is close for us right now.
I actually think that when the political situation changes, that having carbon, like international carbon markets, right, like in the absence of Russia having a carbon market, being able to do the project there anyways, right, with, you know, the funding coming from somewhere else, where people compete for who can mitigate climate change the cheapest, which is kind of the power of the carbon markets. So I think having that be international is going to be a big deal for any other country.
I also just want to make kind of more of a geography point. I know, everyone, it's so exciting. There's a lot of really cool satellite-based studies that are trying to quantify methane globally. And this is also a technique and technology that is being developed. And I think that better measurement and just putting some sunlight on the problem is really the first step. Literally, yeah.
These all use reflected sunlight.
It's gonna help.
I actually remember, one of the reasons I asked this question is I remember seeing some of the data that came out of, there's like a few different international satellites for monitoring greenhouse gases, and so they're much less sensitive for methane than sort of, you know, these techniques which are designed for closer to the ground. But that means that when they see a leak, it's usually pretty big. And you know, occasionally, I think the one they found was in Kazakhstan, and it was just, nobody really knew what was happening on the ground. It was just this like ginormous plume of methane, like the size of like, people on stage probably know, Porter Ranch. It was in LA when like the cork popped on an underground storage, and it was just a giant methane plume. So people, you know, these things happen in sort of like remote parts of Eastern Europe, and we really don't have a lot of visibility into it except through GHG monitoring satellites, kind of the Wild West. Agricultural methane is about 30% of US methane emissions. And I went into this not knowing that you were starting to work on agricultural methane, so that's good to hear. And I hear we have some cow fans in the audience. What can we do about agricultural emissions? So the two main forms that we talk about are cow poop and cow burps. And I guess also rice paddies.
Yeah, I'm going to point to Alex again for, you know, the cows, the feed additive supplements seem to be by far the kind of leading horse in that race. Rice paddies, I actually really haven't seen any great solutions. There was some like intermittent flooding that looked promising for a while until people are like, oh shit, it produces more nitrous oxide, so unclear. There's a couple of biotech companies trying to have rice paddies in like sort of shallow brackish water, right, which wouldn't have any additional flooding, but I think all of that stuff is pretty tough. I think out of the agricultural stuff, the most promising is the cow feed supplements.
Julian, is there a role for monitoring in agricultural methane, do you think?
Probably not with the current implementation we have on a terrestrial vehicle, but you know, the technology has evolved to a point where you can have very good sensitivity and low detection threshold in a device that's couple pounds. So something that can be easily mounted on a UAV, a drone, or some unorthodox, means of locomotion.
Can we mount it on a cow?
That's
Just equip each cow with its own detector.
I wanted to actually ask you if you could talk a little bit more about the current technology. I think I remember it was a ring down spectroscopy, but can you tell us a little more just about how the sensor works?
Yeah, there are a number of different techniques to detect methane and kind of characterize the concentration. So essentially, you're propagating a coherent light, laser beam in the cavity, either in the resonant cavity or some type of multi-pass configuration. So you have enough optical length where you can accumulate some absorption, right? So all these molecules have specific absorption lines. If you can hit excuse me, the gas with the right color, the right wavelength of light, and accumulate enough propagation, you will put a dent in the intensity of the light. And just by measuring the difference of this versus what happens in the absence of the gas, then you can start deriving some concentration information. The cool thing is what we do is we're able to correlate this with atmospheric conditions, especially wind direction and wind speed, and so we can turn concentration measurements into flow, right? And flow ultimately is what our customers care the most about. They don't care if we detected 255 ppb of parts per billion of methane. They want to know how much is this thing emitting. And so the ability to turn concentration into flow is kind of the magic that can really enable doing proper treatment of these leaks.
Aaron, Kairos also uses a spectroscopic technique. Do you want to explain how that's a little bit different?
Sure, yeah, we use the energy of the sun, essentially, instead of a laser. Sunlight comes down, hits the ground, reflects off, and enters our sensor, and methane has this characteristic signal on that energy. And so we detect that, and we're able to convert it into a measurement of excess methane, and then turn that itself into a measurement of flow.
And I know, I remember that we flew some landfills in the past, which can be concentrated sources of methane. Does Kairos have any footprint in agriculture, or do you think that there's barriers to that due to diffusion and concentration and things?
It's a very good question. We certainly have flown over manure sites and we see the methane, but I think the focus of our company and the focus of our technology is to stop methane emissions, and it's a very different proposition to solve the problem of cows versus here's a thing that's broken, here's the exact location, and hey, here's a group of people who actually have access to that site and know how to fix things. Like, go, just connect these two together. So like, it's the shortest path to actually stopping methane very quickly. So even though we can see that methane, I think we're gonna, for the time being, continue to focus on oil and gas because it's just a great opportunity to stop methane.
Oh.
And for manure ponds, like if I know that there are 400 cows and they're dairy farm cows or beef cows, like you kind of know what the emissions are.
Yep. In some hopeful point in the future, we'll have lots more bioreactors, and then they'll start breaking, and then you'll be able to figure out which ones are broken. But we don't have enough bioreactors to make that worthwhile right now.
And if they break, you'll be able to see the oxygen. So as long as you have an oxygen sensor in your device, you know it's broken. It's kind of sweet.
I'm guessing that methane might not be odorless.
The methane is the stuff that's being carried with it.
Yeah, it's usually sulfur.
The sulfur compounds, right? That's the same thing that they put in the natural gas. Rather than me asking more abstruse technical questions, I'd like to see if the audience has any abstruse technical questions or non-abstruse technical questions. Yeah, let me bring you a microphone. Or you can just shout, it's a small room.
I can project.
Yeah.
So my name's Gil. I work at the Environmental Center at Berkeley Law. My title is Methane Policy Researcher. And one of the things that I like to do kind of for fun sometimes is I like to pick a plume and try to figure out who owns it. And I spend time when I do that talking to clerks of courts in obscure New Mexico counties whose names I can't pronounce, and it's kind of an interesting process to sort of try to trace backwards, from a map where a plume is and sort of who is in charge of it. I'm curious for y'all, when you're collecting data, I know you have clients that request the data upfront, but do you backtrack it? Do you find a plume and say, okay, well, let's see if we can figure out who owns this, and let's see if they want to purchase the data, purchase our services, or sort of how that process works?
So the question in general is detecting plumes and sort of what our business model is for.
Yeah, when you find a plume that isn't that a client of yours isn't responsible for,
Yeah.
how do you manage that? Do you do anything with that, or do you sort of try to contact the operator?
I see. So yeah, I mean, we definitely see methane that belongs to operators across the basin. I mean, that's our strategy, right? We actually have strategies of flying full basin surveys so we can understand what does the distribution of methane rates look like here. So we definitely see that. I would say that we do have a strategy of trying to reach out to companies that are in the vicinity of places where we're already flying, because that helps lower our costs overall, and that means that we're getting these detections to people and to get fixed. We also have much more, urgent policies if we see something that is unsafe, an emission near where people are living, or a very, very significant emission that is of extreme concern. We will track down and try to pick up a phone and find a phone number for that emission. So it sort of depends on the context there.
And are they responsive when that happens normally?
It depends. Actually, it's sometimes it's really difficult to get that phone number if you don't know.
Yeah, on our side, we typically work in concert with the utility, so we know their network, they give us their GIS, we know where their pipes are. We draw boundaries and areas of work, together with them. So we typically don't have surprises because we're operating in an area that clearly is owned by someone. Our technology has the ability to discriminate between natural gas and biogenic or sewer gas, because we can detect the traces of ethane that are included in natural gas. So we can do that discrimination on the fly and help our customers distinguish between something that's spewing out of a sewer versus a pipe. So that's the kind of discrimination that we do. Our customers also have a lot of leaks beyond the meter, right, on the customer side, gas barbecues or whatever, random appliances that can leak, and those we pick up as well. So each utility has a different way of dealing with these. So some utilities are very proactive in reaching out to consumers and say, hey, there's a problem in your backyard. Some others are like, not my problem. So it all depends.
No, we'll go around this way.
I was just wondering about the economics of it. The economics of detecting and fixing leaks. Is it only profitable? What size of leaks are profitable to fix just inherently because you're going to save methane and that can then be sold off, versus the markets, and the markets are paying to avoid greenhouse gases, versus like the companies are just doing it for the PR value, like we've reduced methane by 70%. So yeah, if you just talk to the economics of it, that'd be great.
Yeah, absolutely. I'll kind of start at the kind of widest part and then kind of actually work down into a specific example. It's very maybe widest reach for a company to be able to demonstrate that they are pursuing clean operations and reducing their methane. I mean, that is a very, very good message to be able to put out there to your shareholders, and that is going to come back as a return, actually come back in better business. But more specifically, with our clients, we tend to actually see that finding the methane emissions that we report to them, it's not really a matter of saving money, it's actually a matter of making money for them. So about a year ago, one of our clients asked for us to work on a study with them where they actually wanted to understand What is the economics of this? I'm gonna pay you guys to go out and survey. I'm gonna pay my repair crews to go out and fix the thing. All of that has cost, right? But at the same time, I'm keeping this gas in my system, right? And now I'm gonna sell it instead of releasing it into the atmosphere. So how does that work out? And we're like, great, that's a great question. Let's figure it out. So we sat down, we looked at the costs, all of the costs. We looked at the value of the gas. They actually went out and sampled the gas so that we could understand exactly the value they'd be getting on the market. And we found that for this particular customer, it took them 5 days of revenue from that captured gas to make up for the cost of the entire survey, the entire campaign of repair. It was nuts. That's what I said. I was like, this is nuts. Let's look at all of our data. So then I pulled out all of our data across the Permian. We do these large surveys, and we have assigned values to different companies based on what we see. And it's like, okay, let's say we were doing the same exercise with every one of these. If they were a customer, what would we be looking at? And in terms of that particular survey and that particular study, we found that Permian operators would take about 16 days to cover the costs of all of the campaign and repair and everything just by the gas that they were capturing and keeping in their systems. So this is a very, very easy argument to make to a company. Like, you want to stop this methane because this is good for you. And it's really just about being able to put numbers to it and show them the evidence of this.
And that's really remarkable considering how cheap natural gas has been, especially since COVID. I remember frequently the thing, it's like, well, it's so cheap, like, why do people care? And it's actually like, the side, you can capture so much of it back so quickly.
Yeah, on our side, I would say our customers care. They all are in the dialogue with their regulators, right? So the state of California, state of Texas has rules in place that regulates what operators do, how much methane they're allowed to lose along the way, and then how much they can get reimbursed for projects related to abatement or modernizing the infrastructure. So our data is very useful because it helps them quantify the impact of their projects. Like, for instance, if you decide to go after fixing your worst leaks for the next year instead of obsessing over changing pipe for the sake of changing pipe, because it's the wrong material or an older vintage, it really helps them making better decisions how to allocate that capital expenditure, and also to kind of justify to their regulators why they should be allowed to get reimbursed for these projects. So really, our data is a good internal tool to build ROIs and to have a healthier, more proactive dialogue with their regulator. A lot of the regulation in the US and in other countries has been built on really old technology, right? Essentially, if you don't know what you're leaking, you have no idea where your leaks are, what can you do? Best effort, go out and walk around and see what you can find. Everything is built around that. So with better technology, companies are able to have, like I said, a healthier dialogue with their regulators and propose smarter rules, smarter incentives, carrots, and kind of motivations to do better.
Well, your business model is, of course, very different. You're based on carbon credits. So how do you think about how projects turn into revenue?
Depends on the price on the carbon markets. And also there's obviously different characteristics to each one of the different sources. But essentially, at the moment, we don't look at anything less than 50 tons of methane per year kind of emission rate.
One of the things I noticed about, I think one of your slides was that the market price for methane was something like $675 per ton.
Yes, so basically you take the price of CO2 in the market, right? So right now in California, cap and trade, reasonably, I think 27 maybe, and then you multiply that by 25, right? And sort of like the 100-year potential is 28. 1 molecule of methane goes to 1 molecule of CO2. CO2 is heavier, it's done by tons rather than by moles. Whatever, 25. And then you subtract any emissions that you produce in other ways, right? You consume electricity, that gets subtracted out of your carbon offsets. You transport lots of stuff around, you take lots of flights, that all gets subtracted out.
You talked a little bit about how, about the the difficulty of sort of entering carbon markets. Was that a difficult process? Was it very time consuming? Was it very, for a small company?
Depends if you have to do your own methodology or not. So essentially, if you're the first person to be doing something, so the carbon markets work on basically can somebody audit your project? If there was like a frost methane and like an evil frost methane, can an auditor tell the difference with reasonably small amounts of effort, right? And so that means that, it's not like all methane projects are audited in the same way. You have a somewhat different process on, methane from manure ponds versus, something else. And so, on, let's say, the natural sites, there isn't a methodology, so you can sell it in some boutique markets for a little while, but if you really want to go to scale, you have to create your own methodology, and that's time consuming. If there's an existing methodology, for some reason, someone has done something like that somewhere, great, that's a lot easier.
Makes sense. We had a couple questions over here. Okay, Duncan.
Yeah, so my question is, like, the framing around net zero is, like, in the context of, like, I think scope 1 and scope 2 emissions of these companies operating, and they can immediately, reduce the leakage, but when you consider, like, scope 3, it's like, it's still getting consumed by the customers that are getting methane in their homes. So, I'm curious, I guess this is less of a question, more like, how is the industry thinking about this in terms of, like, once scope 3 is factored in, it seems like maybe the tools that are needed to be built around methane start to become different. And then, like, if this, like, on top of that, like, does that pose, like, a risk to the business? Or, like, are you guys already thinking about, like, once everyone's, like, the conversation moves to scope 3, what that means?
And by scope 3, you're referring to the actual use of the methane, the combustion of the methane as.
Right. There's, like, lots of definitions, but if they included that.
Yeah, I think that's a very important point, and you'll notice that a lot of big names out there are talking about scope 1, scope 2, but rarely is there a quantitative commitment on reducing scope 3 emissions. And frankly, I think, if you kind of read over all these reports, commitments, ESG type positions, it's still very unclear how the industry as a whole can reach true, carbon neutrality. So I think, carbon capture and kind of negative offsets are going to be heavily needed for the industry to get anywhere. It's a huge challenge.
How many people here know what scope 1, scope 2, and scope 3 emissions are? Oh wow, cool. See, this is such a highly concentrated group of people who really want to hear about this. I love it. Did anybody else want to address that question?
It's 20 times more concentrated than the regular audience.
Yeah. Good one. We're gonna use that.
I would just add to that, with methane, the impacts that we are seeing are right now. And the industry is absolutely changing. The entire way that we think about energy is changing, but the effects are right now. And I think that all three of us up here are focused on essentially, can we stop the immediate warming here in the next 10, 20 years? Definitely in our lifetime, most certainly in our children's lifetime. And I think that that's really kind of what's driving us.
And I think it's worth to point out that often somebody's scope 3 is someone else's scope 1. So for example, thinking about it from, let's say, the coal mine methane perspective, right? The people that use the coal are utilities or steel, right? And so then that's their scope 1. So I think in some cases, like where the scope 1 is an individual one, I think that gets a little bit more complicated for the accounting, unless you want to carbon tax yourself, and there's very good credit cards for that, just saying. But in the absence of that, I think it's probably like just before it gets to the consumer, it'll probably get accounted for upstream, but when it's another company, then it's their scope 1.
I know we had a question over here for a while. Yeah, you.
Great. Doesn't sound like it is.
Yep.
Oh, awesome. All right. Well, I wanted to start off and just say thank you so much for pulling this panel together. I'm part of Accelerate. We're an early stage climate venture fund, and we've been looking at methane for the past 6 months and having really interesting one-on-one conversations, but to really gather in a place where we're all really interested in this issue is quite remarkable. So thank you for that.
How much would you say that's worth to you? Sorry, no, please ask the question. I'm very.
I heard you mention that earlier. Point well taken. So, I mean, it's awesome hearing about what your companies are able to do in the technology that you've been able to accomplish in addressing methane emissions. And I'm curious to hear commentary just of what kinds of hurdles you've either had to overcome or you've seen moving forward, because hearing satellite imaging from airplanes is, fantastic. And I'm sure that wasn't as easy a process as it sounds to put up. So I'm just curious in terms of either experienced or, in your horizon, what are some of the key challenges that you've faced?
Yeah, I can tell you on our side, it's been a full court press effort for the past 10 years. And by that I mean that we are members of every single gas association in the US and in Europe, and we show up to every single meeting. We participate in technical panels, working groups. We talk to regulators as much as we can. In order for us to deploy our technology in the US, we literally have to go one state at a time. So we have to sell the same story 50 times to 50 regulators who in principle are talking to each other, but they each think their state is unique. And Canada is the same way, and every single country in Europe is the same way, so it's just a painful process. What can speed it up is having mindshare, in DC, having mindshare in Brussels, working with organizations like OGMP, the UNEP, the United Nations, the OGMP process. In the US, the AGA is a very powerful kind of trade association. We are a founding partner or member of the Project Veritas, which is an initiative run by GTI, the Gas Technology Institute, that's trying to build better methodology around methane abatement. So rather than trying to convince every single customer that technology is good for them, we try to work in the ecosystem and really kind of convince folks that technology can help and can be transformative. But it's, like I said, we've been at it for 10 years. So we're finally turning the corner and getting some traction.
So there's lots of legal gray zone for what we do. Are we an air cleaning service or a natural gas extractor? And if so, do we pay those taxes or the other taxes? And if it's leaking into the atmosphere, provably, do we still need to get the mineral rights from those folks? But basically, when you have multiple stakeholders, as you do with surface rights and mineral rights and so on, that's a long site acquisition process. And so that's something that's, the legal gray zones make it a little bit more difficult, and sometimes there's what's the legal answer and where's the answer that's going to piss off the community, and those can be extremely different. And so anytime you're doing anything new, the tech side is always really fun to do the new things. The business side of doing new things, I think, is a little less fun. So for us, it's really been that's been the toughest.
I'll go back also 10 years, because I agree a lot with your answer. 10 years ago, we knew very little about what methane emissions look like out in an oil and gas field. And at the time, our ability to go out and actually take those measurements was pretty limited. We didn't have remote sensing. So generally, the studies that you would see would be someone would go to a site or a handful of sites, 10, 20, do very careful measurements. And they would create a measurement, a database of measurements at these small number of sites. What we know now is that large emissions, the most consequential sources of emissions, you're not going to find them if you go to 10 or 20 sites. You're gonna miss it. And unfortunately, what happened was, because that was the data we had at the time, it was our best guess, the best we could do. There was an entire technology and regulatory infrastructure that was built on incomplete data, an incomplete understanding of what methane looked like. So then when companies like Kairos came along, and we were some of the very first out there flying around doing remote sensing for methane, we didn't know what we would find. We also were very surprised to see the number of very large emissions that are just out in the field, because it was completely lacking in the scientific literature. We just didn't know. And so I would say over the last 5-10 years, a big challenge was just getting people to look at our data and trust our data. We worked closely with researchers at Stanford to do blinded controlled releases so that we could actually have third-party peer-reviewed validation of our technology, show that it's real. We tried to get our data out there in the hands of researchers so that they could look at it and validate it for themselves. And it's been a constant effort to just convince people of the evidence sitting right in front of their eyes. And it hasn't been Kairos alone, there have been other companies as well. NASA as well has been starting to contribute. So I think now we've finally gotten the science and the understanding and alignment between researchers, industry, regulators, academics. I think we all agree that now we're kind of living in the same universe. And now the challenge has become, we've got all of this data, we've gotten so good at measuring super emitters, right? We know they exist, we know the rates that they occur at, we know that they're different in basin A and B, we know that operator ABC in this basin is gonna be different. We have so much data. How can we actually translate that into helping these companies successfully stop methane emissions? We're transitioning from like, is there methane or what is there, to how can we do this really, really well? And it's a huge data-driven challenge, and it's a really, really exciting problem to be working on right now.
And I just want to emphasize what I was talking about before about power law distributions. This is a very strange property of power law distributions, which is that if you take a small number of measurements, you will severely undercount the total amount of emissions. And so people have heard, of Malcolm Gladwell or Black Swan. This is because there's a very small number of these long, fat tail events, and it's much larger. The total emissions from these like extremely rare events is very large, because you only get like one Porter Ranch like every 10 years, but then it leaks as much methane as like the whole oil and gas industry or some fraction of it like during that year or something like that. And so, you just see occasionally these crazy events that are confluence of like 2 or 3 different factors. This is why the power law distribution makes it so difficult, and why wide-scale measurement is so important, and why I love to say that if you can't measure it, you can't fix it.
Don't worry, Matt. The Nord Stream pipeline leak, I called everybody in Denmark to set it on fire.
Oh my God.
Literally everybody.
So I think we got time for one more question. You seem very eager. Yeah.
Hey, my name is Julia. Thank you for all your contributions. So you've touched on this topic, but I would just love to understand this a little bit more. So Aaron, you said we're trying to eliminate the emissions. Julian, I think you said we're trying to raise the bar for our customers, right, so that they can attack smaller leaks basically every year. But what is sort of the renewable component of this problem, where over time maybe equipment breaks down and then there's new leaks, or I don't know, in the landfills, in the coal mines, are there like pockets that are released all of a sudden? I would just love to understand, can we continuously just work toward eliminating this problem, or to what degree can we expect that new emissions are going to happen with a steady consumption every year?
Yeah, I think that this is exactly that flavor of challenge that I was just talking about. We're finding that different companies have different emission profiles, different rates of emissions occurring, different sizes, and it's due to a whole host of factors: the basin you're in, the age of your equipment, your maintenance practices, the scheduling, the weather where you are. That is not the whole list. There's a ton. What we're finding is that it's different, and how you want to balance the technology and the application of your technology is gonna be different. You want to be able to optimize for that particular operator, right? So you want to have the right balance of, say, detection sensitivity, right? Versus how frequently you're going to be surveying, right? So how do you bring all that together to actually minimize emissions to the greatest extent possible, and then just every year evaluate, how did we do, what do we need to update, do it again. and just keep hitting it again and again. And that's how you actually move these companies from, you know, from one position on the graph all the way down to a very, very low emitter.
Yeah, I think a key concept is that it has to be a sustained effort. You're never done. Even the most perfect network or the most perfect operation will always produce leaks. You know, it's a random stochastic phenomenon. You have dirty networks or dirty systems, you have clean ones, but they all will have some kind of residual emissions. So you're never done looking for these super emitters. It's a random process. You have to keep scanning on a regular basis to find them and eliminate them. So what our proposition to our clients is really do this ambitious thing to get your fugitive emissions under control. You'll never get to zero. It's impossible to get to zero because life happens. And find a mix of alternative means to go to that true net zero, meaning inject better gas in your system, mix it with hydrogen. With the complexity that Matt was talking about, you probably have to use different type materials or handle hydrogen in a different way, and then work with end users to convert from gas to electricity where it makes sense. And so it's a whole cocktail of measures. It's job security for me because, you know, these companies will never be done. You know, the minute they stop patrolling their fields, their operations, their networks, leaks come back and the system will leak. So as long as methane or natural gas is used as a means of energy, companies will have to keep up with inspection and monitoring.
Even with hydrogen, you have pretty good job security. It has the advantage in that it eliminates OH radicals, which is the thing that decomposes methane in the atmosphere. So
Yes.
even there. In our case, I think, let's say manure ponds, right? Because that's gonna be easy. So let's say right now, anything, you know, we're interested in anything above 300 cows, you know, the manure ponds from that. As carbon prices go up, or as we get better at running our business and things get cheaper, then you can handle 250 cows, 300, you know, 200 cows and so on. So I think there's, you know, at some point there's just no manure pond. But essentially it's kind of very similar where, you know, as the tech gets cheaper, you can handle smaller and smaller sources profitably up until a certain line.
And just as a final remark, I don't know if everybody up on stage agrees with me on this, and they can sort of furrow their brows at me if they don't, but I think it's fair to say that we will probably not be able to reach net zero emissions while we are still using any significant amount of natural gas in our energy mix. It's currently used pretty extensively for peaker plants because renewables are intermittent, and so during high peak loads, they spin up natural gas generators. One of our very first panels was on energy storage, which is would do, if we can have good long-range energy storage, would do away with a lot of that necessity for peaker plants if there's enough capacity in renewables. So you may have seen in the New York Times last week, there was a whole really interesting article about it's getting difficult to connect renewables to the grid because our grid is so old. Natural gas is going to be with us for quite some time. Berkeley was one of the first cities, I think the first city in the US to ban new construction with natural gas stoves. Joke's on us, Berkeley doesn't build new houses. But with that said, I think we are moving towards a future with very little to no fossil fuel use for energy. And I say that working for a major car manufacturer. But we right now have a problem, and it is one that we can address right now that will reduce warming, and that is important, and it is important work. And if you guys all go out of business because we stop using natural gas, then I think we will find something else to do. So I want to thank all of our panelists for taking time out on a Thursday night, preparing slides, coming out here talking. Please give them a good hand.
You mentioned the work that you're doing at Stanford, and I think that you guys just won a big grant. Kairos did just win a big grant for the DOE, but I want to tell everybody about the Stanford Meta series, the webinar series on methane. So it's Stanford Meta, just Google it and you'll find all of the series of webinars that have already happened and the ones that will bi-weekly, and I saw Oya on there Yep, so
It's true.
check it
It's
out.
one of my favorite ways of staying informed on methane.
Thank you, that's excellent, I didn't even know about that. And I wanna encourage you all to come talk to people if you're looking for a job, find out about what kind of jobs people are offering. And as I always like to say, the rabbis once said, it's not your job to finish the work, but you are not free to abstain from starting it. And so if you ever think about this is a really big problem and we don't know what we're doing and I can't possibly make a difference, you can make a difference if you are doing one thing that can help. And ideally something with a high degree of leverage, like engineering our way out of problems, as opposed to just riding your bike to work. So thank you all for being here. I really appreciate it, having you all here. This is the best part of my month. I love it. We're gonna take a little break from presentation, from panels in April. We had a panel with Berkeley Center for Law, Energy and the Environment planned that we're not gonna be able to do in April, so we're gonna punt to the fall. And I am currently planning a few different topics, infrastructure, we're looking for panelists, and I am trying to pull together the 3 companies working on nuclear technology in the Bay Area. So if you know people at Kairos Power or Deep Isolation and they want to come speak on a panel, you know the one? Okay, great. I've got Oglo on board so far. So
There's also a fusion one called Exemer if you wanted to do that kind of
great. I didn't know. Let's talk about it. Really want to thank you all for coming out here. And yeah, let's give them another big round of applause.
I don't think they're it gets fixed in 10 years. They're saying that 10 years ago.
Sounds like it's actually a large Great job.